What's poppin', dogs? Mr. Allen here, about to graph this rational function f of x equals x squared plus 3x plus 2 over x plus 3. And we've got ourselves a degree that's larger in the numerator, smaller in the denominator, which means we have a slant asymptote or oblique asymptote for this one. We're going to tackle that in a moment. I am excited, though. All right. So domain here. I don't have to factor my denominator. I can see my domain is going to be x cannot equal negative 3. But I am going to have to factor that numerator here. So let's do that right now before we get ahead of ourselves. Anything multiplied to 2 and add to 3? Yes, 2 and 1. So x plus 2, x plus 1, all over x plus 3. All right, so nothing's going to cancel here, so there's no holes, so none. How about our asymptotes? Well, my vertical asymptote is going to be x equals negative 3. So x equals negative 3. We don't necessarily have to specify that that's our vertical asymptote. It's just an asymptote. X equals is going to tell me it's vertical, right? Now, horizontal asymptote, we don't have, right? It's a slant asymptote or oblique asymptote, which means we get to do long division, folks, or synthetic division, your call on what you want to do. And, here we could just do synthetic because there's no lead coefficient in our denominator there. But in the event that there is one, long division is the way to go. So I'm just going to go long division on this one. I know some people are going to be like, bro, just do synthetic. I'm going to do long division, okay? So we've got ourselves, I think I should have some room right here. X plus 3 is going to be on the outside. And then x squared plus 3x plus 2. And even if stuff's like you got a bigger polynomial you're dealing with on the inside here, you really have to do the first couple steps of long division, okay? You'll see why in a sec. X squared divided by x is just x. Multiply that through, we get x squared plus 3x. Draw my line, change the sign. When I subtract, these cancel, I get 0, and then we bring down our 2. And we really don't even have to do that, so that's 0x. So 0x divided by x is just 0, so plus 0. So my oblique asymptote, my slant asymptote, is y equals x. That's it. Cool? If there was a number there, like 3, it'd be y equals x plus 3. All right, but it is just y equals x. So let's plot these two asymptotes here. I'll do this one in pink. So it's going to be at the origin and just up 1 over 1 when I go to graph this. And there we go. Nice. All right. My vertical asymptote, I'll do that in green. X equals negative 3. Lovely. All right. And now, let's see here. X-intercepts. All right. Well, x-intercept will be whatever's left in my numerator after any kind of canceling. And we got a couple things here. I've got x plus 2, so it's going to be negative 2 comma 0. And also, we've got negative 1 comma 0. Right? So it's whatever would make my numerator 0. Why my numerator? Well, if my numerator is 0, then my function equals 0, as long as the denominator is not 0, right? Because then it's undefined. But if I can make my numerator 0 by plugging in negative 2, I've got 0 times something divided by something. That's 0. And over here, I've got something times 0 when I plug in negative 1 over something. It's going to be 0. Okay, so if I can get my numerator to be 0, it's an x-intercept. How do I get my y-intercept? I would plug in 0 for x. So 0, comma, and then if I plug 0 in, usually easiest from the standard form, the original, everything goes away except for the 2 and the 3, so 2/3. Okay. So let's go ahead and plot these points here. I guess I'll go green since I wrote them in green. We got negative 2, 0. We've got negative 1, 0, and then we have 2/3. Okay. So the shape of this graph here is looking something like this, where it's going to come down through those, and then we just get really close to that oblique asymptote. We just get infinitely closer to it over as my x values get larger and larger and larger. Now, where's my other part of the graph going to be? I am going to maybe plug in a number that's to the left of my vertical asymptote, because I want to know, is it up here or is it down here? There's ways you can tell in the equation what's going to happen based on the vertical asymptote. And if this guy was squared, they'd both be approaching the same way. If it's not, it's going to be down here. But I don't like to memorize little things like that. I like to plug points in, okay? So if I plug in, let's say here, that's negative 1, 2, 3, 4. So if I plug in negative 4, I'll do it in the factored form. So f of negative 4 is going to be negative 4 plus 2, negative 4 plus 1, over negative 4 plus 3. I'm going to get negative 2, negative 3, negative 1. So that's going to be what? 6 over -1, so -6. So that means I have the point -4, -6. And just as we were saying there, that is somewhere down here, right? 1, 2, 3, 4, 5, 6. Right down there. And now my other portion of the graph is way down there. All right. Nice. Kind of tiny because we don't have a ton of room down there. But that's oftentimes what happens with these ones with an oblique. All right. Cool, man. It's awesome. Fantastic. A little more here. End behavior. Let's go with end behavior. As we get, let's see here. As x approaches -infinity, this graph is going down to -infinity. So as x approaches -infinity, f of x goes to -infinity. And then, let's see here, as we go to +infinity, this graph is going to follow that oblique asymptote up. So as x approaches +infinity, f of x is also approaching +infinity. Nice. If there's a horizontal asymptote, it's always approaching that value, right? With an oblique, it's going to be going to positive or -infinity because it's sloped. All right. Vertical asymptote behavior. So what's happening around the vertical asymptote? Well, I do have to state from which side we're talking about, right? So we'll say as x approaches -3 from the left-hand side, that means from this side, my graph is shooting down. So that means that f of x, so comma, f of x is going to -infinity. And as, I'll do this one in a different color because they're in multiple lines here. As we approach it from the right-hand side, my graph is shooting up. So as x approaches -3 from the right, f of x approaches +infinity. Cool. That's awesome, man. This is dope stuff. There's a lot going on here on this rational function with an oblique asymptote, but hopefully that helps. Again, you could do long division. You could also have done synthetic division and get the same result. I just prefer long division for this one because it always works. If we had some kind of a coefficient down here with what we're dividing by, you could do it with synthetic, but there's some other stuff you got to do with it, and I just don't feel like dealing with it. So I do long division. There we go. You only have to do the first couple steps anyways. Not a big deal. All right. That's enough. That's awesome. Fantastic. I hope you guys have a great day, and stay awesome.